Alright, we'll go ahead and get started. Today we're going to cover a lot of the basics in Java just to make sure everyone's on the same page. I think we've gone over OOP from a high-level view. We talked a bit about integrating with GitHub and using a little bit of IntelliJ. But now we need to actually sit down and make sure everyone understands how Java works. So hopefully I can sit down and get that knocked out today and then also talk a little bit more about IntelliJ. But before we get to that, please keep sending me your project ideas. I believe on Thursday is where I'm going to present the final list of project ideas, and then I'll ask for what you want. So please go ahead and email me what you would like to work on. It's a lot better when you have a project you like, obviously. But so far I've gotten a couple of good requests. We'll have right now they've been mainly games or apps. So the game, there's text-based adventure, which is a good one. It's not overly simple. There's still a lot of there's drawings. Well, there's also, if you decide to make it actual text-based where you have to type it in, there's some parsing as well. So that was actually a pretty good level of difficulty, but it's not super complex. You're not trying to build WoW or something like that. Blackjack would be another good one. Chess could be a good one as well. Super Mario Brothers or Super Smash Brothers, that might be a little difficult.
Yeah.
That would gotta get scrolling going, and actually controls of a character might take a little for I guess where y'all are right now.
That's probably much easier than actually a lot of those.
Asteroids would be fine, yeah, because what's nice about asteroids, you have one screen and you just have objects moving around and your little ship that can shoot, and then you just have to do simple collision detection with your bullets that come out of your ship.
Space Invaders?
Space Invaders? Oh, you can do Space Invaders. That one's at the bottom. Asteroids is where you can move your guy around. Or at least from what I remember. Maybe it's changed.
I'm probably mixing the two games up.
Yeah, Space Invaders where you have the guy at the bottom, you're moving left and right, and the aliens are Doodle Jump. I thought it was an amusing name, but the idea is that you have one guy and you're just trying to constantly jump up to see how high you can get. I think we had something similar last time, and that's a great one too because it's simple scrolling, but you have one guy and you can just move your platforms around. So that's actually pretty simple.
Yeah, you know when you have the offline page show up for a Google web page, and it shows just that little box with the dinosaur in it. I saw somebody actually create an app for that one for the phone.
So on the app side, these are usually pretty good because you get a nice form, you have to do some calculations, you have to give some feedback. Some of these might be a little oversimplified, but simple for what we're doing, but a lot of them at least is a good place to start. The body fat calculator, that might be a little too easy because that's something I'd probably assign in the lab. But maybe general health calculations and maybe some recording what you've done today, and then calculate how many calories you burned and maybe what your projective body fat would be in the future, or something along those lines would probably be a good level project. So nutrition tracker, kind of combine the two. That'd be a good project. Daily fitness reminder. Let's see, different areas. So yeah, this one actually would be cool because when you log in, you have to basically query an internal database about what part you want to work out today, and it keeps track of that for you. Tells you what you should be doing, so that could be fine. Financial budgeting, that's also a good one. Just a way, you now need to configure how you're doing your budgeting and maybe a way to track all your finances and then show a report afterwards of what you've done. So that'd be a good group project. Car/hotel rental/reservation. I don't know, who wrote that one? I don't know if I exactly picture what's going on, because if you're trying to reserve something, you're going to have to mock the reservation in the background with the hotel. And that might be a little tricky. But that one could work as well. But yeah, so a lot of these are pretty good so far. Really just the Smash Brothers is probably too, I would say, difficult at this point for how much programming maturity we have. And then the body fat calculator by itself would be too little, but if you combine it with a couple other things, it would be good. And the rest are probably on par about what I'm looking for. Except maybe original Mario might be too hard as well. But
what is the original Mario anyway? I've seen so many different versions of Mario.
So if it's Mario, just Mario Brothers, then do you remember? Well, hold on, I don't remember. You play Super Mario Brothers 3? No.
I played one for the Sim 64.
Nintendo 64. Wow. Showing my age. So it's one screen. You have basically different platforms. You have Mario and Luigi, and the idea is you have two pipes on top, and it'll spit out enemies, and you have to defeat them, kick them out into the water. Yeah. If you've seen that before, that's the original Mario.
Oh, okay.
Then there's of course Super Mario Brothers, which hopefully y'all are familiar with that one.
Where the one where you're trying to save the princess.
That's the one where you're trying to save the princess. Yeah. Regular Mario Brothers, you just kicked them off into the water that was underneath. They never really saw. But anyways, okay. Oh yeah, any other questions about this? If your idea is not up here, please email me again. I just probably missed it when I was going through all my long list of emails. Welcome. Okay, so let's go ahead and get started. I was going to cover this on the first day, but we didn't get to it, so I'll make sure we get that today. A little bit more about program development in Java. This is probably a review for most of y'all with C++, but let's at least go over and make sure we're all on the same page. In general, for right now, when you're developing, you write the program in a language like Java, and then you have a compiler that translates the program to something a computer can execute. And then if you have problems, you usually investigate and fix errors. That's probably, in general, what y'all have been doing up till now, and that's fine. Good morning.
All right. So you remember my baby from last semester?
Yeah.
All right, well, we had an incident. The baby got loose, couldn't find him.
Wow.
He climbed under the cabinet and was playing hide and seek. I didn't know he was playing.
But he knew?
Yeah, he knew.
He knew, okay. But he's okay now? He didn't fall out of the cabinet?
I never found him.
You never found him?
I had to leave the house to come to class.
But wait, how do you know he's in the cabinet?
Because I heard him screaming.
Wait a minute.
I never bothered to go find him.
Oh, okay.
I just heard screaming.
So your roommate's got to take care of him.
No. He's
Kill
just
me.
going to sit there the rest of the day. There's macaroni and cheese somewhere in the house. Yeah,
All right.
Awesome stories.
Yeah, thank you, Tyler. Nice way to break it all up. So we have an idea of levels of languages, and in general we have 4 different kinds. You have the machine code, which is what the machine is actually executing, what your computer executes. Assembly language is really just an English simplification of machine code. High-level language, and that's what we are programming in. That's what C++ is, as well as Java and other languages as well. And then 4th generation has to deal mainly with databases where you're describing what you want, and then the compiler tries to figure out what you want it to do. So we stick with level 3, and the idea is just so you understand that your compiler is translating from your English to assembly, and then assembly into the machine code. Also, each computer has its own specific language. Did y'all go through that in C++? There's x86 is what these machines have. Your phone is probably running ARM, but there's a whole slew of other languages on the computer, MIPS, Spark, PowerPC, tons of other ones. But the job of the compiler is to translate it into that language. And that's what happened in C++, is that it would translate your code directly into either x86 or ARM, et cetera, et cetera. The reason I'm telling you this is that, that's what I just told, is that Java's approach to this whole paradigm is going to be different. Let's see. Let's go to the picture, because that's what makes sense. So in Java, what's happening that is actually different is you take your source code, it goes through a compiler, and then it produces Java bytecode. So it's not actually, your compiler is not actually producing the binary code, it's producing an intermediate code called Java bytecode. When you go to run your Java application, you have to send it through another Java interpreter / compiler, which then, while it's running, translates it into machine code. This is why when you want to use Java programs, you have to install the Java JRE first before you can run it, because it has to have the interpreter on your machine. In C++, there's no C++ interpreter. It just compiles your program directly into machine language and then moves on. Can anyone take a guess why Java did it this way?
For like the public and private, right?
Public and okay, it's something similar to
So
that.
like, if you're a programmer, you go through the compiler, and then if you're just running it, you go through the interpreter.
Yeah, you just send it through interpreter. So why would, in Java, it compiles to the bytecode, and then when someone wants to run it, they run it through the interpreter, and it runs on their machine. And what I'm saying is in C++.
So one person, the people that are running it don't have to have the
Compiler.
what?
Right. Now the question here is in C++ is a little different. You have your source code, it goes to the compiler, it goes directly to the machine code. In other words, it does this. You'd have your C++ code, go to your C++ compiler, spits out the machine code, and then runs the machine code. Notice there's a lot of steps in between. Why do you think Java wants to do it this way, or decided to do it this way?
To help eliminate potential errors.
Help eliminate. Okay, yeah, that's actually a good point. Because now, if it's in your bytecode, the interpreter can pick up a lot of different errors at runtime. So yeah, that is actually a good point. But that's not the primary reason. It has to do with this. I mentioned earlier, how many machine codes are there?
Tons.
Tons of machine codes, different ones. In actuality, there's also a machine. When you build your program, it also has to build it or package it for your operating system. So while you may have x86, it has to package it for Windows, for Linux, or if you have Mac or Solaris, et cetera, as well. But in Java, it just packages it to a bytecode, and then you run it later on. What advantage do you see there? If you're in C++, let's say you compiled it on Windows x86, but now you want to run it on an ARM machine, maybe your mobile, your phone. In order to, your mobile's running ARM, can it read x86? No, it cannot. It cannot. So what does the person have to do? You have to go back here and run through the compiler again to produce the ARM. In Java, it's different. Instead of having to run through the compiler, you have your bytecode, and now you just run it through the interpreter. So how many times did you actually have to compile it?
Once.
Once in Java. So you compile it once in Java, you give everyone your Java bytecode, and as long as they have an interpreter, then they can go ahead and just run it on their machine. So the advantage here is you basically compile once, run anywhere, is the idea. While in C++, you'd have to recompile it for each individual machine code. Y'all see that advantage? Can anyone take a guess of a disadvantage of doing it this way?
You have to have an interpreter.
You have to have an interpreter, first off. They got to install interpreter. Someone's got to write that interpreter for the system as well, so that might be a little difficult.
Then they gotta compile the interpreter.
Well, we'll assume that that's okay. That's not a big problem. Yeah, so they got to have an interpreter. Anything else? What do you think is better when it comes to performance? This is a trick question. Well, this is kind of a hard question. It goes straight to machine code and runs, which is what C++ does, versus going through an interpreter and then writing machine code. Which one do you think would be faster?
Straight to machine code.
Yeah, so there's this performance situation where in C++, just being able to load it up and run the machine code can be faster. Also, you'd have to load up a Java interpreter, which historically have been really slow, although they've gotten a lot better in recent years. So there's a lot of cost or overhead up front.
Oh, well, cool thing. So, like, you heard the game Roller Coaster Tycoon 2?
I've heard Roller Coaster Tycoon,
Okay, well,
so they made a second one.
we got it. There's like 5.
And there's 5? Okay, sure.
The guy that made it, he made the entire game
Mhm.
in assembly language.
Hmm.
So that's why you can run on any computer. Now, back then when MS-DOS,
Right, because you have to actually have DOS. Because since it was an assembly, it was a machine code, and it was actually tied to the OS as well. Yeah. But if you wrote it in Java, then it
they
was
wanted to make it run
it would
with
just
no
run
problems, make it
yeah.
real easy.
Although, if I recall, Roller Coaster Tycoon was what, 90s?
Oh yeah.
Yeah, so A, it's probably before Java, and B, it would have been really slow at the time if it was in Java. Okay, so our development environment, first off, you do have to have the Sun Java Development Kit. It's now called the Oracle Java Development Kit. I really need to update the slide. You have to install that first. Make sure you do have the JDK. I think everyone's gone through this. The DK is so you can actually have the compiler and run it. The JRE is just so you have the interpreter and can run already compiled programs. But you need the Java DK, JDK, in order to compile. Now there's different IDEs. For this class, I'm supporting IntelliJ. It is something that's being used a lot. A lot of people have, even my past summer, used it for compiling Java. Google, some people at Google will use IntelliJ as well. But that doesn't mean it's the only one that's out there. Eclipse is still popular. I've seen plenty of shops use Eclipse. I've heard of people still using NetBeans. That one seems to be going in and out. Really depends on the time. BlueJ is another one. But also, just so you know, you can always load up Notepad. Is that how you added in C++ with Notepad, or did you use Studio?
Notepad++.
Notepad. Oh, okay. Oh, okay. Notepad++. So you can.
I must blame Dr. Hayes.
No, that's fine. That's fine. That was a good example just to show you it's really just text. You can do the same thing in Java, but hopefully you'll see with IntelliJ, when you have an OOP language, it can be really helpful to use an IDE. But you can use Notepad++ to write your Java if you want to. I'm not going to stop you. The details of these environments differ, but the basic compilation execution process is the same. Okay. Just get a couple terms straight, because I'm going to teach this a little differently than Hayes. Hayes did a good job, but I talk a little different. The syntax rules of language define how we put together symbols, reserved words, and identifiers to make a program. So the syntax is the actual text that's going in there. The thing is, or syntax. When I talk about syntax, there's no meaning behind it. They're just literally what is being typed out on the screen. The semantics is what we define as understanding or what the program means or what it's supposed to do. This is why you want to give your functions names that make sense. Sum of something. Then that semantically you know what it's supposed to do. Syntactically, it's just how it's being typed out. The reason I differentiate this is a program that is syntactically correct is not necessarily semantically correct. Have you run a program where it compiled and it ran, but it didn't do what you wanted? Yeah, so that's an example of syntactically correct, but not semantically correct, because it's not what you meant to do. Okay, errors. There are 3 types of errors in general. The compiler can find a syntax error. Then if that happens, the executable does not exist until you fix it. You've probably had that in Mississippi College. A problem occurred during execution that causes the program to terminate. For example, divide by 0. Have most of us experienced that? Divide by 0 or some floating point error? Okay, great. Then your program done. And then the third one is the program runs but produces incorrect results. Probably maybe an incorrect formula or something else. So the question here, if you had to order these from easiest to solve to hardest to solve, what would be the order?
Well, the compiler finds the error. It's usually pretty easy.
It's usually pretty easy.
Logical errors would be pretty hard.
Logical ones are pretty hard.
Then you got to go back and figure out what your own error is.
Yeah.
And there's no
So you got to find it, right, and then fix it. If it's divide by 0, you at least have a good idea about where it is. So you just need to go there and then figure out how that happened. So really, the top one's the easiest, the bottom one's the hardest. The one in the middle is somewhere in between. Another picture might be you edit, save your program, compile it. There's an error. You got to edit, save it again. Otherwise, execute, evaluate results, and then go back. It's easiest to catch the error compile time, or hopefully while you're designing the program in your head. It's far easier to catch errors there and fix them than when you already have a program running. So when you want to design your program, and I'm going through these steps because this is how you really should be doing it. Of course, a lot of the labs here, it would be overkill to do it this way. But when you go, you actually do a full project in the workforce or your class project. Please do it this way. I'm actually going to force you to do a couple of these steps just to show you why it's important. But first off, when you approach a large problem, designing an operating system or something, first you want to understand the problem. What does it do? What are you trying to do? What are you trying to accomplish? What do you need? And then once you have those specifications, you usually have to talk to the customer and figure out what's happening, what do they want. Go and design the solution. Consider some alternatives, which is always good because if someone's already solved it for you, don't reinvent the wheel. Just copy, paste, and call it a day. But chances are yours is unique, at least in a couple of areas, so you'll have to maybe tweak someone else's solution or rewrite it from the ground up. Then you go ahead and implement it and then test the solution. Hopefully y'all seeing at least testing is somewhat important if you want to be correct. In this class, actually, have any of y'all encountered the autograder yet for this one? It went up, I think, on Friday. So if you resubmit your lab, you may have to submit it twice. The autograder will actually give you a grade, testing with its own test cases. Naturally, this is not purely linear. They overlap and interact. Why would these overlap with each other? Has anyone actually done software engineering in the workforce yet? Yeah. So a very popular thing that happens is the customer will tell you one thing, and then you'll code it, and then they'll say they told you the other thing.
Yeah.
What?
Those people.
Those people. It happens all the time. So unfortunately, when that happens, you got to go back to the beginning and redo it. It's also a reason why you need to, when the customer writes something down, tells you something, write it down, send it to them, have them at least sign it so you can say, hey, look, we agreed on this, and then move forward. Let's see. So y'all have done divide and conquer. I call it divide and conquer. Sometimes they call it functional decomposition. But the idea is you have a problem, you divide it up into pieces, and then you solve each of the pieces. OOP is very good about this. All right, let's see. Proper development consists of establishing the requirements, creating design, implementing design, and testing. Maybe not in that order. Test cases should be considered during design. The quality of code, which determines how well we test, should be considered during requirements. So that's a great question. And this brings it up. If you're quality of code, let's see. How much testing should you do? Ooh, here we go.
A lot.
A lot.
Enough.
Enough. All right. How do you determine what's enough?
When you can't think of a way to make it fail.
Can't think of a way to make it fail. Okay. Well, maybe. Okay. It's a good start. So if you're designing an app on your phone versus a piece of health equipment that's keeping someone alive, which one needs more testing?
Oh. The second one.
The second one. Okay. Right.
I actually have experience with that.
Oh.
My dad.
Personal or
business,
okay,
yeah.
family. Okay.
Well, I helped him out. He was building hospital beds, and I had to help him design the program to make the computer work, to keep everything moving, and a lot of testing.
Mm-hmm.
Because if one thing failed, that person was going to get hurt.
Yes.
Something bad was going to happen.
But
Lots of lawsuits and.
But if you're, your random, I don't know, nutrition app or something, or grocery tracking app fails on your phone, hopefully people aren't going to die from it, right? So you don't need to.
Don't be so sure.
Right. I'm sure that someone can find something, but the point is.
It can randomly make your phone blow up.
Sure, whatever.
It's possible.
It's possible, just unlikely.
No, somebody didn't test the Note 7.
Yeah, the Note 7 is not even allowed on airplanes anymore.
Yeah. They said, we test that enough.
Did anyone die from? Did someone die from that, or?
I don't know. I just saw it in baggage.
Someone got burned, but no one has died yet.
They explode, apparently.
Explode, but well, if no one's died yet. That might be a good example.
That I forget what university, they made phone batteries that have like fire extinguishers inside the batteries.
That's
If battery
crazy.
explodes, it immediately stops.
That's
I mean, that's
amazing.
good. That's
That
kind
was
of.
the
That's
class
genius.
project.
That is a genius. That's
Wow.
pretty good. Oh, that's kind of
We
weird.
got a problem here. Let's just destroy everything while we're at it. One thing goes wrong.
The whole phone's out.
The whole phone's gone.
Just
All right.
instead of
So testing, you got to also assess how much testing you need to do. If it's an app, usually you want to push it out because the end user can be the tester, right? In a way. But if it's, it's a piece of health equipment, you better test that thoroughly before it goes out. All right. So lastly, before we actually jump into Java, software requirements specify what the program must accomplish. They usually called a functional specification. The design indicates how a program will accomplish its requirements. So the requirements are what the user wants it to do. The design is how you're going to accomplish it. And what do we got? Implementation is the actual source code, and testing is the act of ensuring the program will solve its intended problem under all constraints. We're going to go a lot more into requirements and design when we start working on the class project. But I want to get you a good high-level view of what's happening. Okay. All right. Done with that. So now back to Java. How far did y'all get with lab? Is it lab 00 or lab 01? What should I call it? 00. Great. Good. How'd that go? Anyone finish it?
Yeah.
A couple people finished. Got the flower put up. Okay. Perfect. So first off, whenever you create a class file, it must exist in the classname.java file. This is a convention of Java. It's just what it has to be. For example, if I was over here and I had my Hello World file, let's see, where are we? Lab 00, CSU, grading, all of the best, CSU 325, spring, all, there we go, all of the West, Lab 00. If I were to do a listing on source, csci, you can see that it's called helloworld.java. IntelliJ takes care of that for you, but if you try and change the name of Hello World to something else, sadness is going to occur. Hello 2 is public, should be declared in a file named hello2.java. It actually tells you. And if you do try and compile it, it's not going to happen. It's public, should be named in that file. This is just something Java requires. So we'll go ahead and save that. And now I'm going to right click on it and try and run it. And then it'll come right up. Okay. We talked a little bit about public. What's public?
It's accessible anywhere.
Yeah, anyone can see it. In general, your first class of a file should be public because you want anyone to be able to access your class. So public, and then class, you're actually declaring a blueprint of an object, and then followed by the name, and then inside you put in the class body inside of curly brackets. Now, you don't have to have the curly bracket on this line. That's something I do. You could have it this way. That's perfectly fine. I'm not going to take off points either way. Did Hayes make you do it one way or the other, or just as long as your formatting was consistent?
What are you talking about, the curly brackets?
Yeah, the curly
We
bracket.
did them like that.
Y'all did them like this? Would we take off points if it was like this? Or you don't know?
It would probably just annoy him and he would move it.
So I do it this way. Other programmers do it Hayes' way. The important thing is to be consistent. Notice on my function I put the curly bracket on that same line. But I have everything still tabbed out as you would expect. So just be consistent in your files is really is what matters the most right now. All right.
So each time we create a public class, it's got to be in a new
File.
file.
Each time you create
So
a
how do we? This is going to sound dumb, but how do we create a file? How do I create a new file for a new class?
So when you use IntelliJ and you go new class, it automatically creates the file for you.
Okay.
If you want to do it on your hard drive, you just open up Notepad and then open or save it as helloworld.java in the correct location. If you want to do it that way. Is anyone going to be using Notepad++ or considering it? IntelliJ is probably going to be the best for at least the beginning. Okay. So you have Hello World. Let's see. So this is just the class heading. And then down here, you might have function function heading. And then inside, we have the function body. Notice that a function is inside of a class. Functions have to be inside of a class. You cannot put a function outside of a class. It will not work. In Java as an OOP language, everything has to be part of an object. Therefore, functions must be members of objects or a class. Let's see. And then, of course, you can have your method body. All right. Again, you want to have public, at least for now with your function, saying anyone can access this function. Static means there's only one. Really, that's only important right now for main. Don't worry about too much anything else with static. None of your other functions, for the time being, should be static. They should all just be public, and then what the return type is, and then the name. So here, of course, is void. It's not returning anything. But just like in C++, you could have int or double or float or string, etc., etc. When you're inside of the function, if you want to call a function, you can first off put in the class name. So let's see what we got. So the class name. Ooh, that's going to be hard to see. See how I did it over here. Oh, okay, good. So for example, here's your class name, system.out. The method name is at the end, so print ln, and then the argument that goes to the function. Here we go, hello world. So it should look somewhat similar to C++, except for there's this object in front of your function call. Did y'all do any object.function calls in C++? Not too much? No. So right now, remember your function has to be a member of a class. So you got to put the class name first. Oh yeah, lastly, one thing that's going to be a little odd starting now, and I'll show you a little bit, is I do not need a main function in order to test your code anymore. Because since you have an object, you've already packaged your code up in a module, aka a class, and I can separately run main and do some of my own testing when I want to. Okay. Any questions so far? Must be a tiring Monday morning. All right.
I do. I
Yes.
don't really understand I understand that if you have a new class, it's got to be in a new file.
Right.
So, can you just go over real quick how to create a new class and get it, name it right? And
Sure.
create something new in there?
Let me jump over here. Right now I'm in lab 00. I'm going to see, well, let me go ahead and save. Let's see if have I created a class code for this one yet? Let me find out. CSU. Let's see, courses, spring 2017. There we go, class code. Is that a project? All right. So the nice thing about class code is I've already, this is a, wait a minute. Come on. Class code, do I have SR? Okay, so I have not created the project. I'm going to go ahead and create a project called class code, and it's going to be part of the courses repository. That way when I push something, it'll appear under class code. Namely, let me show you under GitHub what I'm talking about. If I'm over here, 325.17, class code isn't here yet, but I'm going to go ahead and create it and then be able to push it. That way you can see all the class code that I make. But first I need to go ahead and create that project. Let's see, Quest, CSU, courses, spring 2017, class code right there. Boom. All right. Overwrite it. Okay, class code, SRC. So for your labs, the first thing you want to do is make sure you have that package. So under SRC, where you right-click on it, you go New, Java Package. We did this last time, but I'm going to do it again. CSU.csci 325. Hit Enter. And then when you want to create a new Java file, You just go right-click on the package, New Java Class. What would you like me to create?
I guess something similar to what we would be doing for the lambdas do this week. So you can just do like a tree.
A tree class. All right. Tree. Yeah, so we got a public tree class. Maybe inside of a tree, you'd have public double height. You could return, I don't know, maybe it's a 32. All right, 32.4 in meters. Let's see. What else do we have? We have public. What are we going to have? Oh, double width. Got to spell width right.
The tall tree.
It is a pretty tall tree. And I just went to autopilot, so I'm going to start slowly. So I created the tree class, and that automatically put the tree class in there under class code CSU/CSCI325 and then tree.java. So it automatically created the tree.java file for us.
Okay.
And IntelliJ already gave us a nice stub of what tree was. If I want to put a function inside of tree, I make sure after tree I go public, make sure it's public, return what I wanted to, double the name of the function. I'm not passing any parameters. Open curly, close curly. Since it's returning a double, I'm just going to return 32.4 for now. And maybe I'd also do public int age. We'll say it's 67. And I can make more and more functions this way. Okay? Good question. Any others? No questions? All right. All right, let's make sure a couple more things are clear. Writing classes. All data types are objects except primitives. Make sure that's burned in your head. Everything is an object unless it's a primitive. So unless there's only a small set of primitives that are not objects. Everything else is an object. The primitives are byte short, int, long, float, double Boolean, char. The giveaway of primitives is they start with a lowercase letter. By convention, all your Java classes start with an uppercase letter. Please stick to that convention, otherwise it might start getting confusing for you what's going on. But yes, all those are lowercase, therefore int a is a primitive, but integer a with a capital I is actually an object. It is not a primitive. One gotcha is when you do an array inside of Java, it's actually an object as well. Because an array is not a primitive, Java is going to treat an array as an object itself. That contains a bunch of either other objects or primitives. All right, any questions? Let me show you why that can be why that's different. So if I were to go up here and go private double height, and then inside I can also create something called a constructor. Have we talked about the constructor yet? The constructor is the function that is called when you create the object. So whenever an object is created, a constructor is called. Now there could be more than one constructor, but this function is always called when the class is created. So here I might have mHeight equals 32.4, and I just realized I'm not sticking with what I meant to. So mHeight equals 32.4, so when it's created, it's going to set mHeight to 32.4, and then in here I can return mHeight. Another thing I do is I can make another private, but this time integer, mAge, and now I would want mAge equals new integer, and what do we have, 67? 67. So what's the difference here? Ooh. We have mHeight is a double. It's a primitive, so we just set what its value is equal to. mAge is an object, integer. Is it hard to see back there?
A little bit, yeah.
A little bit. See, does this make it worse? Oh yeah, it makes it worse. Okay. Feel bad because now it's like we're doing dark, secretive things, but oh well.
It's part of the job.
It's part of the job. You gotta get used to the darkness. All right.
Get used to hunching over and typing all secret numbers.
Hopefully he'll get used to at least moving around as well. But notice m height I just set the value, but m age I had to create a new object called integer and set its value in there to 67.
So could you have just made it private int mage and then just mage equals 67?
Yes.
That would be primitive.
Then that would be using a primitive.
Okay.
Right.
So with a
Let's go ahead and type that out. Let's do this. So this is object primitive. There we go. And then down here, object instantiation, and then let's see, primitive assignment.
do you have to put new in front of objects?
Yes. Because you are creating a new object, you have to instantiate the object. Because image is not actually storing an object, it is pointing to an object. This is
So
kind of-
can you do another new integer with a different number in it?
Yes,
Would it become a list or would it replace it?
it would replace it.
So with m height, it would replace that too? If you were to change that later on?
Yeah, because we're now storing the variable. You know what, let me jump down, let's do some test code so you can see how manual testing works. So I'm going to write public static void main string args, and I'll go ahead and create a tree object. Tree equals new tree, and then system.out.println tree dot, let's see, what do we got? Height. Now if I right click on tree and I run it, .4. Why do I have to create a new tree first?
You can't print something that's not there.
Yeah, you can't print something that's not there. In other words, if I try to comment out that and that, if I go system.out.println height, ooh, that actually doesn't make any sense. Non-static method cannot be referenced from a static content because there hasn't been an object created yet. Inside of main, you haven't created an object yet. It's just running main for you. So you can't just call height because there's been no object created. Now, you might think that we could do tree.height, but again, non-static cannot be referenced to static contents. We haven't created a tree object, so that's not legal either. So I'm going to go over here and put not correct.
No correct.
No correct. Thank you. Go down here and also do tree dot. That's also not correct. Comment those out. And then we'll complete those, put them down here. And then you can see create a tree object, print out the height. Okay.
So tree equals new tree creates a tree variable in the main function so that you can print it.
So tree, we're going to first create a variable called lowercase tree that points to a capital tree object. Then we're going to create a capital T tree in memory, and we're going to store a pointer to that object inside the lowercase t tree variable. So lowercase tree is pointing to the object we created over here. Next class, I'm actually going to, or one of the classes coming up, we're going to talk a lot more about memory, because this can be a little confusing if you don't see how it's actually working in the machine. But notice that right now, it's actually creating a separate tree object, and then lowercase t tree is pointing to that object. And then what we're saying here is, in that object that tree is pointing to, call .getHeight. So it jumps to that object and calls getHeight. Okay?
Is that the conventional way to create a main function? Is that how we're going to create every main function?
Yeah, a main function has to be created this way.
With that line of code?
Yes, public static void main string, solve bracket args.
Okay.
You can call it something besides args if you wanted to, but everyone calls it args. So
Like, you could just call it anything.
yeah, you could literally type in the word anything, it'd be fine.
So what's the point of that? Just space.
What's the point of what?
Args. What is args? Exactly?
Argument. So when you go and you learn about, actually you'll learn this in next class in data structures, but in operating systems, when you run a program, you can send messages to it or commands to it when you start it, and that's what's being stored or being passed in as args. If I brought up the command line, I could show you this real quickly. And then you can investigate what args has inside of it. A lot of times you might be sending flags to a program. You may have, when you're using a GUI, taken one file and dragged it on top of a program. And if you ever do that, what you're actually doing is sending the path to that file to that program, and it sends it through args, essentially. But we're not going to be dealing with it. Just type in string args and just go on. Okay. So I didn't talk about, yes?
When running, so in C++, we would have to compile it and then run it. Here, we just right click and run, and it does all of it. Is that
Yes,
correct?
because we're inside of an IDE.
Okay.
And it's going to automatically do it. We could load up the command line and do it from there. Is that what y'all use, the command line? With
Yeah,
the
we did.
Oh, nice, nice, awesome. Well, we're going to stick with an IDE for now. But if you want to do it from the command line, you definitely can. I won't stop you. Unfortunately, start becoming a headache with all the objects you have to deal with. All right, so inside of age, I haven't finished this, but we actually want to call age dot, what was it, int value, which returns the integer value of it. Notice I had to call dot int value because age is an object, and we want to return a primitive. Convert object age to primitive int. Now, in our current version of Java, it would actually automatically do this for you. I think you can just do return age, but that's because it's actually calling .int value for you. But I'm just being explicit here so you see what it's doing. Ooh, all right, good question. Any others? I'm going to show you what I'm doing when I commit the code. I'm going to go ahead inside enable version control, put it up on Git, hit OK, right click on tree, add it to Git real quick, VCS up arrow. We don't want to do that. Just go tree class code, commit and push, push. One file. Would you like to move to another? Nope. Push successful. Now if I go over here on Git, on the class page, I do a refresh, class code's up here, and you can actually now look at tree.java. And next time you pull from upstream, it'll actually pull it to your machine as well. So that's what I mean by I need to commit the code, is I need to go ahead and drop it into the correct location for y'all to view. Okay, where are we? Talked about primitives, good. Strings, string str. So is string an object or a primitive? Object, it's an object. Declares a reference called str to an object of type string. The object has not been created. Later on you do new string hello world creates an object. It stores the reference pointer into str. How is this different than C++?
it converts the object to the string on its own without you having to do it.
In C++ or?
No, this.
Oh, okay. Which string library did y'all use? Or did y'all just use character arrays?
String.
You did use string? Was it the standard string or?
Yes.
Okay, so you use standard string. So it's going to behave very similar to standard string, except for you have to always put in new. Well, you don't always actually, but you put a new string. So sticking with our tree example, we could go down here, go private string mtype. And what type of tree do you want it to be? Mtype equals new string.
Green tree.
A green tree?
Green tree. Mix it up. Now it's not a type of tree. Now it's just a tree. That's the color. We just mixed it up, man.
What type of tree should we make?
Mahogany.
Birch.
Birch?
Yeah.
Did I spell birch?
Yeah.
Good. All right. So this is the full code. Now, in Java, with strings and only strings, you're allowed to do a shortcut. You don't have to do new string. You are actually allowed to do this. Mtype equals birch. There we go. And that's fine. But only strings are you allowed to do this. You can't do this with other objects. I'm going to comment that out. And then down here we want to do public string. And this time I'm going to use the proper heading, get type. We'll go ahead and return mtype. And then down here I can of course go system.out.println tree.getType. That'll print out the type. Hey, I put a little equal sign right there. That's cute. All right. I'm going to run it. And I'll go and print out at least a birch. Most of the capabilities from your standard string in C++ are basically the same in Java, except strings are immutable. Yeah, so you can do a hello world. That's a shorthand. Showed you that real quick. But since it's a string object, you can get the length. So for example, on the next line, you could do system.out.println tree.getType.getLength. Oops. .getLength. Or .length actually is what it is. It's not getLength. And I'll tell you the length is 5. All right. Any questions about strings? All right. Okay. Real quick about package. Java has a lot of packages, or a lot of classes. What is it, 4,240 in Java 8 library? Hopefully, if you can see that if you tried to list them all and just use them, it would get pretty ridiculous. In fact, if you ever want to go and look at the Java library, you can just go over to Google and just type in Java string. Actually, you just type in the class you want. That'll probably give you a link to the docs, docs.oracle. Let's go with overview. Here are the different packages that are available. Oh, it's not going to give you the full lab. What about class? Oh, okay. Well, before I go into that, let me go and explain it. Packages, you have over 4,000 classes. They need to be organized. So Java uses packages. This can be similar to namespaces in C++. You import packages just like you would include in C++. If you want to import the scanner class, you do java.util or import java.util.scanner. Now you can use the scanner class. See if we go up here. Well, I'll go and show you. You have a ton of different packages. A lot of different packages. Probably the most popular one that you'll be using is java.util. You can create a bunch of different classes here, but you noticed here we have, where's scanner? There's scanner. Click on that and notice that it's java.util, that's the package, and then scanner is the class name. And actually this, you actually can see a full description of what Scanner does, gives you code examples, a lot of them, tells you constructors and all the methods that you can call on Scanner as well. So if I was over here in Tree and I wanted to use it, actually I'm going to create a new class. Right-click, New, Java class, Scanner, Scanner Fun. There we go. Go and add it to Git. If I want to use it, I would go import java.util.scanner. That way I can go public static void main. And what the scanner class does is it scans, well, any type of something from, or any type of input stream. We haven't talked about streams, but one very common input stream is your keyboard. So you can do scanner equals new, oops, scanner, scan equals new scanner from system.in. And you can system.out.println scan.next. What do we got? Next line? Next line. If I were to right click on Scanner Fun and run this, it will echo what I type. And then ends. So at least you can see I can import the scanner class. I'm going to create it inside of main, and then I can use it later on, is the main thing here. Scanner class, if you ever want to do input output from standard in, which will happen in your next lab, you can use the scanner class to quickly do that. Okay, string math random scanner. All right. So how's it going right now? We just went through a lot of material. Good so far? Let's review for Tyler. How are you all doing?
You said the auto grader was up?
The auto grader should be up.
It's actually working this time.
It's working this time. Thanks. Yes.
When I type that system.out.println in another file, it's the system. The word system is in red.
Is it capital S?
Thank you for your help.
Not a problem. Okay. Let me stop recording here so I can break it up a bit.